Welcome to Easy Aid Tutoring. Let's look at the benefits of pre-preparing your lab book. It takes experimental sessions and makes them become learning experiences. A well-prepared lab book takes an experimental session from just completing a checklist to a controlled, reflective, and educational experience. This is especially valuable in chemistry, where timing, stoichiometry, and careful observation really matter. It forces you to plan properly and enhances the understanding of the theory behind the experiment. So, in order to write down aims, objectives, background, list your reagents and apparatus, and write out a method, you actually have to go and read your experimental guide beforehand. And this takes you from just passively following the steps to understanding why each step is performed and what we hope to achieve. Writing your theory and equations in your own words, it helps you to strengthen your long-term understanding of the underlying chemistry. Now, this can be useful if you don't just use your experimental guide, but you also use additional notes, which can also help to strengthen your background when you need to compile an extensive report later. It saves time and reduces stress in the lab. So when you already have your pre-drawn structure, for example, you've put down templates of tables, graphs, an observation section, and the calculations that you need for a specific experiment. And these calculations can just be the empty equations where you filled in data that you can before the experiment, and leave open spaces for data that you acquired during the experiment. This helps you to focus on performing the experiment and recording your results accurately. So you don't need to wonder where to write down what to record, and you can focus on handling the equipment. It also frees up mental energy to focus on the technique that you are applying and helps with problem solving instead of focusing on the logistics. It improves your data quality and completeness. So when you have your data organized in one place, you won't forget key measurements, conditions, and qualitative notes. And you also can do comparisons with expected values much more reliably and complete. Having your method, raw data, and preliminary calculations already organized in one place makes analysis and write-up easier afterwards. So your post-lab calculations, error analysis, and formal reports become much faster to complete and clearer. And sometimes when you have a space in the experiment where you are waiting for something to happen in the experiment, you can actually start doing some of these calculations when you have all the equations and everything, all the equations, the data already set up beforehand. It also creates a transparent audit trail of what was planned versus what actually happened, reducing the chance of missing key information when compiling your final report. It reduces errors and wasted materials. So if you think about the quantities and dilutions in advance, you can prevent simple calculation errors. Knowing what you should do beforehand helps you notice when something goes wrong early. When you anticipate common errors, it helps you to lower the chance of repetition or starting over, and you get more reliable results when you have fewer repeats, and you also waste less reagents. It also helps support safety and risk awareness. So you know what types of hazards the reagents, solvents, and reaction conditions can create, and you know how to handle the situations. You also know if you would require special or additional safety PPE in advance. This is now obviously on top of your lab coats, safety glasses, closed shoes and long pants. It also helps you to anticipate or know what types of waste you are producing during the experiment and if they need any special handling. Knowing what types of emergencies can occur helps you to know which emergency actions to take and when to locate the safety equipment. Now, of course, if you are in a lab and something happens, like you burn or cut yourself, you do need to inform your demonstrator or the lab manager. It helps to build good scientific habits. So, for example, when you prepare beforehand, your tutors or demonstrators can easily check whether you understand the experiment and typically also reward preparation marks. Now, for professional practice, this is a very good habit to start forming very, very early on. And when you are doing advanced studies, research, or industry, it's always good to have a prepared plan before you walk into the lab. Now, for earlier in your undergraduate studies, you may get a practical guide, an experimental guide, which you can refer to. However, sometimes when you are a bit later in your studies, these practical guides won't be provided and you would be expected to go and find your own experimental method, and therefore already having this discipline built early on helps you later on. A prepared lab book is a very powerful learning tool, and a typical format is you have your aims and objectives, your background theory written out in your own words, you have your key chemical equations, your safety hazards and required PPE, a list of your reagents and the amounts of them, what you need, and a list of your apparatus that you need. Possible experimental setup, especially if it's something complicated or you need to remember something specifically. You need to have a concise outline of your procedure, pre-prepared data tables, preliminary calculations, and always also leave a space for questions if you had confusions while preparing your method. Then you can ask your demonstrator to help you clear up your confusion. Thank you for watching. I hope this helped. Please like and subscribe for more educational content.